So last chapter we were before we were talking about circles, we were talking about these, and this is just a typical parent function, and it's had some stuff happen to the parent. It's been moved and it's been flipped and all that kind of stuff. Would you on your scratch paper start by writing down all the changes here? And I'll give you a second and pause while you're doing that. Okay, so the main things that you guys found were that it was flipped, up, down, flip. That was over the x-axis, or reflection. That's 2 times taller, or stretched vertically with a factor of 2. And that spot's kind of important. It's the vertex of my V shape. All right, that's just a quick review because what we're doing now with circles is a lot alike. Here's a circle equation. You learned this last class. Okay, so let's see. Dr. J, tell me what you know about this. In this case, do we call that a vertex for this particular shape? It's a center. You are correct. And then what? How come not 16? And here's why we need to square it. If you go back to this little equation, see the little x and the little y there? And I say x squared plus y squared is equal to this distance squared. It's a Pythagorean theorem. So x squared plus y squared equals 1 squared. So there's the parent. That's why we need to square that last number. It's because it's x squared plus y squared equals the radius squared. So technically it could go like that, except we don't put that because 1 squared is 1. All right, I'd like you to write me the equation for this purple circle right there. Write me the equation for that purple circle. Okay, now we're back from the pause there. Let's see, who can I bug for this? Lizzie, what'd you get? And you're saying then that that -1, -3 would be its center, and that is correct. And then that 4 means that the radius is 4. What do you think the most common mistake thing to put right there would be? 2. Because people think, oh, the radius is 2, so I put a 2 there, and you forget to square it. All right, good. Now talk about this purple circle in terms of being a function. Is it a function or not? No. Doesn't pass the vertical line test is the way most people say it, but there's another way to say it in terms of inputs and outputs. Okay, if I look at the input for this spot right there, I'm trying to go right on the line, but alignment's off a little bit. The input is -1. What's the output? -1 and -5. So I've got one input giving me what? 2 outputs, and that's not okay. You're not supposed to have that on a function. All right. So now, give me the equation for that one. Sarah, what'd you get for that one? Did I write what you said correctly? Okay. So you're saying that it's been moved 3 to the right, and instead of it seems like down 1, it's actually up 1. Didn't we used to be able to trust the y's? But now you're saying -1 when it seems like it should be +1. Why? It's in parentheses, therefore it's counterintuitive. Good. And this 9 means that the radius is really what? 3. Raise your hand if you had that one right. Excellent. Okay. Then, do you remember, oh, that's just the general form for any circle. You always can start by writing that stuff. And then you can fill in the blank spots like here and here and here. And that's, what your circle will look like if it's in standard form. If I solve it for y, do you remember, this is just notes from the other day, that when I put the square root on top here, that it means that I get the absolute value of y out? You remember that? And when you have the absolute value y, it splits it into two equations. I got the green one here and the blue one. What's the difference between the green one and the blue one besides one's green and one's blue? Nick? Exactly. The blue is the upper part of the circle when you graph it, and the green will be the lower part of the circle. And separately, those are functions. But together, they're not a function. If you ever want to graph one, you just graph those two things. So all we really did is solve this equation that we started with up here. We solved the parent equation for y, and then it comes out to two things. Because we know that when you take the square root of a variable, you get the absolute value of like this. And that's what makes it two equations, the green one and the blue one. All right. So that's pretty much all we did the other day when it came to circles. Is there any questions that you have about circles that you want me to explain to you? Only hearing crickets. I think that's enough for the recording for today.